নোট কতজন আছে তোমাদের এই সেকশনে? আচ্ছা, বেশি নয়। আগের ক্লাসটাতে 37 was the number. Nearly double. This is a normal number. In almost all IITs, the number of students in a year never exceeds 50. So is with the NITs. We are taking 140 and on that. People want to study in Jadavpur, so let them study in Jadavpur. Thing is that whether that study still carries the same weight. Everything has to have a kind of balance, how much resources you have and how you can distribute or utilize that resource in teaching students. If without applying your mind, the number of students is increased, well, the resources become absolutely useless. And the entire process that is followed becomes much less effective, almost ineffective. Once any of the things deviate from the normal, if the number of teachers become too small, if the number of students become too high, both of them equally affect the course and learning becomes difficult because after all it doesn't materially affect the teachers, but the students have to learn. If the process is inaccurate or rather ineffective, the students are the main losers. So they are getting chance, they're getting certificates, but the value of the certificate is likely to get diluted if the teaching becomes ineffective. But nobody could think about these things in depth. So the obvious, the inevitable is happening now. Jadavpur's reputation is going down fast, like anything. And have you ever attended any of my classes? I mean, not online, but offline classes. This is the first time. So you'll find me a very bad teacher because I am simply out of tune now with this process. Online teaching is not supposed to be real online. Online teachings were there. Course models were prepared by very famous universities abroad. But there what they did is that the entire thing was filmed with the application of multimedia and all that. The figures were there, the figures were changed if necessary, the diagrams were there, and then speech came. All those were coordinated by the multimedia experts so that it's kind of directing a film. Ultimately, the product is ready after lots of designing and experiments as well. And then they are put on air so that people who are absolutely motivated, because people have to pay for these modules and courses. So people properly prepared, ready for the course, and are motivated to the full. They attend it, and because it is so nicely designed, it becomes effective. But just you can see the teacher or just listen to him, and one or two still photographs can be shown to you. That's not the way teaching can be done, at least in engineering, where you have evolution of the diagrams, you have the mathematical deductions progressing with time, and when all those are on the classroom board, you can have a look at them and you can always follow it. Even if you have missed a moment or so, you fail to follow the teacher, still you can catch up. But here, everything is snapshot. No continuity with the past is possible. So teaching is simply not happening. but we cannot afford to lose years after years like this. So we have to continue. You are very unlucky that when you are the students, such a thing is happening. Anyway, we have to try our best as much as we can so that the class at least becomes meaningful. I will not be really stressing upon every detail that I can afford to do during a normal class, but I will try to impart a kind of idea from which, if you are sincere, you can learn further and know it in detail. But my initial goal is to say something meaningful so that we are not lost as to what are the things being done, why are they being done, and what do you do that. Such confusions so that they are at their minimum. That will be my goal today. How much time? Oh, 10 minutes are passed, so we can start. Yeah, an impulse generator is an equipment, and there will be an input to it, and there will be an output to it. If you have studied a little bit, at least, the instruction sheet, and you know about the impulse generator a bit theoretically, then you know that the input is a DC voltage, and the outputs are shots of impulse. They are not permanent outputs. They appear and they disappear. They have a wave shape. The wave shape is decided by the circuit parameters, and they can have variable peak voltages depending upon how much DC you fed to it. So the first thing that in our experiment we have to do, or whenever we are supposed to use an impulse generator, is called the calibration of the impulse generator. Calibration doesn't mean calibration of a thermometer or some other such calibrated meter, but here the calibration carries a different meaning. Here the calibration's purpose is to let you know how much DC voltage will create how much peak voltage at the output peak of the impulse. Is it clear to you? Calibration means how much DC voltage you can feed to give what desired peak you need as the output. Right, that is called the calibration. For that, we don't, yes. My voice is cracking. Is it okay now? Okay. So how much DC voltage you need to feed to the impulse generator so that you get the desired peak voltage at the output impulse is called the calibration of the impulse generator. Our problem is impulse generator produces the impulse. There is no direct instrument to tell you what is the peak voltage. In an indirect manner, we have to measure the peak voltage. Let me tell you one thing. Since I'm accustomed to teaching in English, I'll be speaking in English. But if you have to pose any question, please pose it in Bengali. I will explain in Bengali. There will be no problem. So what we do is that at the terminal, the output terminal of the impulse generator, output terminal of the impulse generator, we connect a sphere gap. Means two spheres very close to each other, but still there is a small gap between them. Now these spheres in our laboratory are of 25 centimeter diameter. And the gap between them is 1.4 centimeter. You will see there is a table which shows that corresponding to 25 centimeter diameter spheres with a gap of 1 centimeter between them. 50% breakdown takes place at a certain voltage peak. Precisely, the number is 42.9 kV peak. What is 50% breakdown? Impulse is such a nature of voltage which doesn't have any critical such value like AC or DC, where in AC and DC there is a certain critical voltage level below which any voltage will not cause a breakdown at all, above which any voltage will definitely cause a breakdown. That is a simple situation in AC and DC. Yeah. But in impulse application, since the breakdown of the gap depends upon generation of initial electrons within the gap for the breakdown process to take place, and this generation of initial electrons usually have a statistical delay time. It's not always constant. So if the delay time is too high, then the impulse will attain its peak, and then gradually the voltage will decrease. The electrons are coming out much late, so no breakdown will take place. Luckily, when the impulse will be coming out much earlier, the electrons will be coming out from the electrodes much earlier, then the breakdown will take place. So there is a statistical aspect. At a certain peak, for a certain sphere gap, with the diameter fixed, with the gap fixed, how much kV peak produce 50% breakdown? That means if you apply 10 shots, 5 shots out of that will produce breakdown. That voltage can be experimentally determined, and there is a table in the IA specification, which is in your instruction sheet as well, that for 42.9 kV peak impulse application, if 10 such applications are consecutively made, 5 out of them will produce breakdown if the peak is 42.9 kV. Do you understand? Yeah. So, but again, this 42.9 kV peak is not constant. That means, depending upon the air pressure, the moisture in air, and temperature of the ambient situation, this kV peak slightly varies. And for accuracy's sake, we have to take this variation into account. How do we do that? We introduce correction factor. Correction factors are mere coefficients. The UN, normal voltage, they say, that is 42.9 peak. It will happen only when the situation is STP, standard temperature and pressure. Right. What is standard temperature and pressure? It is defined in your instruction sheet. Please go through it. 760 millimeter of mercury, some temperature in Celsius, etc. If there is a variation, a deviation from the STP, the temperatures change, the humidity is changed, the air pressure change. So, in these changed situations, the peak for which there will be 50% breakdown will no longer be exactly 42.9, but slightly different from it. How to get that number? You have to multiply 42.9 kV, which is the breakdown, 50% breakdown, by a certain coefficient or correction factor. Okay, how to calculate that correction factor? To calculate that correction factor, you need to have the data of how much is the dry bulb and wet bulb temperature of a what is the kind of thermometer it is called, which has a dry bulb and wet bulb temperature? You have studied in school. Do not remember? Anyone? Does anyone remember how they actually help to measure moisture content in the air by the difference in dry bulb and wet bulb temperature? Can you explain just by basic physics? Can anybody explain to me? Then I am reassured actually. Too much explanation will make you distracted. So that's why I want to minimize the amount of explanation that I have to do. If you already know that, okay, let me just in a brief statement tell you. If it is a very humid condition, then there will not be much vaporization. When water is there, water is continuously getting vaporized, evaporated. And when getting evaporated, they are taking the latent heat from the bulb of the wet bulb temperature thermometer. So the thermometer is showing lesser temperature. The dry bulb is not dry bulb of the dry bulb thermometer is not dipped in water. So it is showing you the actual ambient temperature. But the wet bulb will be showing lesser voltage. The more humidity is, less evaporation will be there, less latent heat will be taken. So the lessening of thermometer reading for the wet bulb will be even less. That means they will be very close to each other. But when it is relatively dry, there will be much difference between the wet bulb thermometer reading but placed side by side. One is dipped in water, one is dry. It is taught, I am sure, in every school it's taught. So when it is absolutely dry, there is much difference between the wet bulb temperature shown by a thermometer and the dry bulb thermometer, what temperature it shows. But when it is very, very humid, when it reaches saturation, that means no water evaporation is possible, then they are almost close to each other. A certain graph is given in your instruction sheet, which helps you to find out what is the gram per meter cube moisture content in air from the dry and the wet bulb temperature. Once you get that gram per meter cube moisture content, it is called H. Putting that H and the delta value is relative temperature and pressure, gives you the delta value. There is another formula in the instruction sheet itself. If you just have the dry bulb temperature and the barometric, you can calculate delta. If you have H, you can calculate K, the coefficient factor, the coefficient correction factor, and then you can determine actually for your ambient condition, for what voltage peak application, there will be 50% breakdowns. This voltage will not be very different from 42.9, but slightly different. But if we can accurately calculate that, we can accurately measure indirectly what peak has been created when experimentally we are finding that 10 shots are producing 5 breakdowns. You slowly increase the DC voltage. As you increase the DC voltage, the peak of the impulse created is also increasing. You do not know what is the peak voltage. But when, for each step, you are applying 10 shots. And then again, if say initially out of 10 shots, only 1 breakdown takes place. Then you raise the DC voltage a bit, and the impulses, they now create 4 out of 10 discharges. When it is 5 out of 10, you just take a note of the DC voltage. This is the DC voltage for which Such an impulse is being created whose peak is correction factor multiplied by the normal expected voltage 42.9 Vp. So now you know what is the DC input voltage corresponding to the output peak. We are not going into the wave shape of pulse because wave shape is fixed and according to what you want, that is ensured by the circuit parameters, the resistances, the inductances, the capacitances. Okay, so this is the major part of the experiment, the calibration. How much DC voltage creates how much peak of an impulse generator. There ends the experiment. But at the same time, because this is the first time you are getting exposure to the equipment, you need to know how impulse is created by the DC voltage. Obviously, AC voltage is rectified to give you DC voltage. Now, what is the AC voltage source in a laboratory? It is the CAC terminal voltage 230 volts AC, RMS. You apply it to the primary of a transformer, raise it to a kV level at the output of the transformer. And then there is a circuit which is called doubler circuit, which not only produces DC, converts the AC into DC, but also doubles the value of the voltage. Almost doubles the peak value of the voltage, almost, but nearly doubles the peak value of the voltage. That particular circuit is called the doubler circuit. Now, do you want me to explain how it works? You already know. You already know, isn't it? Can you identify the two figures I have given to you? They are the lower figure. The bottom one is for the doubler circuit, and the top one is actually a single stage impulse generator. A source capacitor is charged by the DC voltage source. Then at a certain point of time, you decide to artificially trigger the gap between the two spheres. As the gap triggers, now this source capacitor starts sharing charge with the output capacitor CB, the ballast capacitor. And it charges through a resistance RD, which is called damping resistance also. And the voltage rises across the ballast capacitor because now it is getting charged from the source capacitor. How fast it rises? That within 1.2 microsecond, in 1.2 microsecond, it reaches the peak. That means when terminal voltages of both the capacitors are same, there will be no longer any charge sharing because there is no voltage difference at all from between the two ends. Now it is time for the capacitor, the output capacitor, to discharge to earth through an increased resistance. The figure shows that the increased resistance is RD plus RE. So since the discharge resistance is more, the discharge rate will be slower than charging rate. So within 1.2 microsecond, it reached its peak. But within 1.2 microsecond, it will not come down to 0. It is a much slower decay, so slow that in 50 microseconds, it comes down to half of the peak just reached by 1.2 microseconds. Whatever peak voltage was reached, half of that, it decays down to half of that value in 50 microseconds. Okay, so that is a single stage impulse generator. But when we need to increase the peak many times more, then we actually add several stages of capacitors so that When initially one sphere gap breaks, we intentionally break them, help to break them. Then the potential, the base potential of the next capacitor gets raised, so its output voltage, its terminal voltage at one terminal is much raised, doubled. The next capacitor gets an addition of this much voltage, so its one terminal of it is raised to 3 times the DC voltage. Thus, as many stages are there, that many times you can raise the peak of the voltage in the impulse form, and peak of the voltage DC, which was the input voltage. So just several parallel capacitors with appropriate sphere gap arrangements can increase or multiply the peak of the impulse several times, depending upon how many stages are there. That is actually all about the experiment. Do you have any question? No, those spheres are not gaps, but they are connected, just acting as solid connection. Why? I will explain for everybody. Because you cannot take away physically the capacitors. They are so heavy and very costly. They must not get damaged or anything. So once for all, the setup, the assembly is there. What you can do is, by some trick, you can manipulate how many number of effective stages will be there, although there are actually 8 capacitors. 8 maximum stages are possible in this circuit. But if you want, say, 4 stages, if you want just 2 stages, what to do? Simple. If you want 2 stages, make a cluster of 4 capacitors parallel to each other and solidly connected. They actually act as a net capacitor, which increased capacitance, 4 times the capacitance. Okay, 4 capacitors solidly connected in parallel are actually equivalent to 1 capacitor. Another 4 equivalent to 1 capacitor. So now it is effectively only a 2-stage capacitor. It can only double the DC voltage in the impulse speed. If you want 4-stage, you can make 4 such groups with in each group 2 capacitors parallel to each other. So now they act as a 4-stage impulse voltage. And when all the capacitors are unconnected to each other, then it becomes an 8-stage capacitor. Right? So that is all about it. And the data is provided to you. How to write the report is clearly written there. So write down the report. Why wait for 7 days? Just do it now. And I'm not pressurizing you to submit it now. Better to submit it as early as possible. So you are free of any anxiety or worry. The last group, they submitted it exactly after 7 days. That's not necessary. Anyway, the choice is yours. I'm not forcing you, as you find it convenient. The data is given somewhere. Somewhere in the instruction sheet you have been given. In every experiment, the data has been given, I have been told, with which you have to fill up the tables. Here, of course, you don't have to. Guess why? Because only at a certain DC voltage, you have to see whether 5 out of 10 shots it is breaking down. That is your experiment part. Okay, so what is the DC? That voltage must be given to you somewhere here. Or you can ask, it is usually, it should be for 42.9 or voltage around that, it should be half of that if it is a two-stage impulse generator. So half DC voltage will be doubled for a two-stage capacitor and two-stage impulse generator, and it will make it to 42.9. Some voltage loss in the circuit takes place. Usually it is 23.5 kVdc or something like that. Is it not written anywhere clearly? Actually, nobody can write. Only experimentally you have to find. Usually it is 23.5. Okay. You type for 23.5 kV DC at the input, when the impulses are produced, 10 shots produced, 5 breakdowns. That means 42.9 kV is the output. kV peak. It can be transformed into a slightly altered voltage depending upon the ambient situation, the moisture, the temperature, and the pressure. And you can just, those temperatures and pressure values should have been given to you. Right. I think that will help. Okay. Okay. Thank you very much then. And please send me the list of attendance. There are 23 students. How many were there actually, you said? Oh, okay. Now, including me, it shows 23 means someone is absent. So if he comes later, he can definitely submit the instruction sheet. But since he has not listened to me, supposedly not learned a lot of things, he will get slightly less mark. Okay? Okay. Thank you. Okay.